In today's basic organic chemistry class, we'll be looking at carboxylic acid derivatives. Carboxylic acid contains carbonyl or acyl group that is bonded to hydroxy group. So when this hydroxy group is replaced with another electronegative atom or group of atom, we form derivatives. This S, which is the hydroxy group, when it's replaced with halide, we form acid halide. Acyloxy forms anhydride. Alkoxy forms esters. Amine forms amide. Thiolate forms thioesters. Phosphate forms acyl phosphate. So these are acid derivatives formed by replacing hydroxy group by all those mentioned. This hydroxy group is represented by X. So when X becomes all the above mentioned, we form their respective acid derivatives. These are common acid derivatives. This is carboxylic acid. The highlighted with green is the hydroxy group. So this hydroxy group, when it's replaced with halide, acid halides are formed. It can be acid chloride, acid bromide, or such like. So the halides are the halogens. You can form anhydride. We have esters, we have amide, thioester, and acyl phosphate. These are examples of compound obtained or derived from carboxylic acid. That's why they are called acid derivatives. The reaction pattern of this acid derivative is when hydroxy group, which is a nucleophile, is replaced with another nucleophile. The nucleophile can be halogen, alkoxy, amine, thiolate, or phosphate. Now, how do we name acid derivatives? Starting from acid halides. By naming acid halides, the two last letters of carboxylic ic acid. When you replace the ic acid ending of carboxylic acid with -yl, we are going to form an acid halide. Example is ethanoyl chloride from ethanoic acid. Instead of saying ethanoic acid, that IC of acid is replaced with YL, becomes ethanoyl chloride because we are dealing with chlorine. Benzoyl bromide instead of benzoic acid. That IC of benzoic acid is replaced with -yl, and then we put the halogen, which is here bromine. So we call it benzoyl bromide, ethanoyl chloride. Now, looking at the last compound, we are making use of cyclo compound. This cyclo compound has 6 carbon, making it cyclohexane. And at the end, we have carbonyl chloride. So whenever you're naming a ring that is not aromatic ring, you name it as a cyclo compound. Then the acyl aspect of this acid chloride is named separately from the cyclo compound. So we have cyclohexane carbonyl chloride. To name anhydride, we talk about whether the anhydride is symmetrical or asymmetrical. Now, if the carboxylic acid that is being used to form this anhydride is symmetrical, meaning they are similar carboxylic acid, we are going to name the name of this carboxylic acid and put anhydride. But if it's unsymmetrical or asymmetrical, it means that we are going to look at alphabetical order. Example, we have benzoic ethanoic acid anhydride, in the sense that we have 2 carboxylic acid that form this anhydride, and they are ethanoic acid and benzoic acid. So we're going to name them alphabetically. B comes before E. So we have benzoic ethanoic acid anhydride. This is IUPAC name. But if we want to use the generic name, remember ethanoic acid is called acetic acid. So we talk about acetic benzoic because we are using the general name of ethanoic acid. But if you're talking about IUPAC name, benzoic comes before ethanoic. This is for an anhydride formed by asymmetrical acid. Naming amide. With unsubstituted amine group, replace the oic acid or ic acid with amide, or by replacing the carboxylic acid ending with carboxyamide. This carboxyamide is when you're talking about cyclo compound. Let's look at the examples. The first compound, remember the acetic acid is ethanoic acid. That hydroxy end of that ethanoic acid is replaced with amine. So we call it ethanamide in terms of IUPAC. But because the general name of ethanoic acid is acetic acid, we call it acetamide. But normally in exams, IUPAC name is always used, but you're supposed to be familiar with both IUPAC and the general naming. The second now, we have hexaneamide or hexenamide. Compound is supposed to be hexanoic acid, but the hydroxyl aspect of hexanoic acid is replaced with amine group, so we call it hexenamide. An amide, where the hydrogen of the amine is replaced with alkyl, we are going to name it by talking about this alkyl aspect of the amine. The example is when we have N-methyl propanamide, meaning that this amine aspect of this amide has a substituent called methyl. So calling N is talking about assuming you have aliphatic compound and you have a substituent on carbon number 1. We call it 1-methyl. So that is why we are using N-methyl. The second compound, we have both hydrogen replaced with alkyl. So we call them N-diethyl. Assuming I have methyl and ethyl, I will say N-ethyl and N-methyl because they are different. But when they are the same, we talk about NN, just like in straight chain, we talk about 1,1-dimethyl. So that's why we're having NN-dimethyl. But remember, whenever you're naming a cyclo compound, you're going to name that cyclo compound different, and the derivative aspect also different. So when we have a ring which is pentane, we have cyclopentane is a ring, then the amide is called carboxamide. So that's why we have cyclopentane carboxamide. So in the last compound, where we have NN-diethyl cyclohexane carboxamide. So like we talk about in acyl compound, the same thing we are talking about in amide. So you name the cyclo compound, then and add the derivative aspect separately. I hope that's clear. Naming of esters. In naming of esters, esters are named as alkyl carboxylates. The alkyl aspect is from alcohol, while carboxylate is from carboxylic acid precursor. Looking at the first example, when you see a compound like this, it's not compulsory that your alkyl aspect will always be at your right hand, while the carboxylate will be at the left. No. How do I know alkyl and carboxylate? The carboxylate is that aspect of compound that is going to bear the carbonyl. So the part of the compound that bear the carbonyl is the carboxylate. So in this case, the carboxylate is our ethanoic acid, while the alcohol aspect is one that is going to have the isobutyl. And the isobutyl is also known as 2-methylpropyl. So that's why we'll talk about 2-methylpropyl ethanoate. Means that 2-methylpropyl is the alcohol aspect, while acid is ethanoate. Looking at the next example, we realize that where we are getting our carbonyl is methanoic acid. So the alkyl is from benzyl alcohol. So that's why we're going to have benzyl methanoate. This is very important. So when you see an ester, go and look at the carbon that bears a carbonyl. That is the carboxylate end. So the others becomes the alkyl end. So you name the alkyl before the carboxylate. Naming of ester, like I said, you talk about the alkyl before the carboxylate. Example we have here is ethyl ethanoate. Look at the carbon that bears the carbonyl. So the carbon next to it is the acid precursor. So the one that is highlighted on green is the alkyl, which is from alcohol as precursor. So that's the same way esters are being named. But like I said in other compound, when I come to cycloester, then I have to name the cyclo compound and end with carboxylate. But in this compound, we have a tertiary butyl as an alcohol aspect, while the cyclohexane is the carboxylate section. So that's why we'll talk about tertiary butyl cyclohexane carboxylate. So the highlighted green is alkyl, which is tertiary butyl, while the part that bears the carbonyl is the carboxylic acid precursor, which is cyclohexane carboxylate. How do we convert carboxylic acid into acid halide? In the last class of carboxylic acid, we talked about that carboxylic acid can react with thionyl chloride or inorganic halide to form acid halide. So the same thing, this acid halide is a derivative of carboxylic acid. So chemistry is always interwoven. So whenever you learn A, you're going to see A when you get to B, like a chain reaction. So that's why some topics are treated before the other, because you need the knowledge of first to understand second. So for us to form acid halide, we react carboxylic acid with thionyl chloride, phosphorus tri or phosphorus pentachloride. That's when I'm talking about acid chloride. But if I'm looking for acid bromide, instead of phosphorus tri or pentachloride, I will use phosphorus tri or pentabromide. Chloride and bromide are only used in this reaction because they are more reactive. So in this reaction, our target is the hydroxy group to replace with halide. That's what will form our acid halide. When converting carboxylic acid into anhydride, 2 mole of carboxylic acid is needed. It can be the same carboxylic acid. Example of same carboxylic acid is when 2 mole of acetic acid is heated at very high temperature. Then we're going to eliminate water, forming anhydride. Because it's the same acid, we are going to call that acid once and put anhydride. So this acid is acetic acid. We call it acetic anhydride. IUPAC name of this is ethanoic acid. So we call it ethanoic anhydride. Esters can be prepared from carboxylic acid using different routes. The first route is first converting your carboxylic acid into a salt. Then the salt will react with alkyl halide to form an ester. First, convert the carboxylic acid into a salt by reacting with sodium hydroxide. So we're going to form that hydrogen will go and sodium will replace. So we're going to form sodium ethanoate. So this sodium ethanoate is going to react with alkyl halide to form our ester. but this method is limited to primary alkyl halide. The common reaction we know is carboxylic acid reacting with alcohol under acid, which is HCl, or sulfuric acid as catalyst to form an ester. But this is limited to simple alcohol. Now, the next method is first converting this your carboxylic acid to acid chloride. Acid chloride is more reactive version than carboxylic acid. So if you have carboxylic acid and you have acid chloride is more reactive than carboxylic acid. So when this carboxylic acid is first converted to acid chloride, then it can react with alcohol under pyridine to form ester. This is a general method. So it means that the best method of preparing ester is from acid chloride, not from acid itself. So acid chloride will react with alcohol. Looking at the two methods, you realize that the second one and the third one are the same. The difference is their starting material and their catalyst. In the first, which when we are using normal carboxylic acid reacting with alcohol, we need a very strong acid, which is HCl or sulfuric acid. But when we are using acid chloride as an acid, we don't need any catalyst again. We just need solvent. That's why we employ pyridine as solvent. The starting material here is very reactive already, so we don't need any catalyst to catalyze it. Because carboxylic acid is not very strong, that's why we need a catalyst to hasten the reaction into completion to form ester. But when we're using acid chloride, we don't need any catalyst. We just need a solvent that will help the reaction to occur smoothly. Hence, the best method of preparing carboxylic acid is from acid chloride. This is a reaction of conversion of acid into ester. Carboxylic acid can react with alcohol using sulfuric acid or HCl to form an ester. Reversible reaction of this is called hydrolysis. So when I do esterification, I'll form an ester. When I hydrolyze, meaning my ester plus the water, which is the product, going back, I'm going to form my reactant back. So that's why it's called a reversible reaction. So whenever you see any reaction that has to do with acid and ester is being formed, go and look at a point of attachment. Is a point where there is carboxylic acid connecting to hydroxy group. If you look at this compound of mandelic acid, realize we have two hydroxy groups. Not all hydroxy group can be removable. The second hydroxy group cannot easily go. The first one can easily go because of the carbonyl compound. The carbonyl compound can easily let hydroxy group go. So that is why it's only the hydroxy group that is being removed, not the other hydroxy group. The hydroxy group that is removed there is one that is connected to carboxylic acid. We have different classes of amide. We have primary amide, we have secondary amide, and we have tertiary amide. Primary amide, there is no substitution, so we have NH2. The two hydrogen are there. In secondary, one hydrogen has been replaced with alkyl. In tertiary, there is no hydrogen. Remember, the same thing with primary alcohol, secondary alcohol, and tertiary. The primary alcohol have two hydrogen, secondary have one, tertiary have none. So that whenever you see primary, secondary, and tertiary, irrespective of the compound, they follow the same pattern. In naming amide, the ic or oic of acid is replaced with amide. For secondary and tertiary amide, the alkyl group bonded to nitrogen are named, like I said in the previous slide. Now this compound, we want to name it. We name it N-ethyl N2-dimethyl because the first methyl is both on N and on carbon number 2. Remember, if I want to start naming, what I need to name, the carbon that bears a carbonyl is carbon number 1. Remember, the one on N is a substituent. So the main group is the carboxylate. So in that substituent, we have N and N. And in the main compound, we have another methyl. So we talk about N, 2, just like saying 1, 2 dimethyl. So we have N-ethyl. Remember, this N is serving as a number, no more as a letter. So remember, in naming, number and letter we separate with hyphen. So that's why N is serving as number. That's why we put N hyphen. Then, and when number and number come together, they are separated with comma. That's why we say N, 2 dimethyl propanamide. Preparation of amide. How is amide prepared? Amide are prepared by reaction of acid chloride with ammonia. Remember, acid chloride are the most reactive version or most potent version of carboxylic acid is the acid chloride. So in acid chloride, when I add ammonia, I'm going to form amide. When I add primary amine, I'm going to form amide that is N substituted. When I use secondary amine, I'm going to form amide that is di substituted. Aminolysis means when you convert acid halide into amide. So the process of converting acid halide into amide is called aminolysis. When you react acid chloride with ammonia, you're going to form primary amide. When you react with primary amine, you're going to form secondary amide. When you react with secondary amine, you're going to form tertiary amide. This is the reaction of aminolysis, like discussed in the previous slides. So depending on your acid halide or acid chloride, it will correspond to the amide that is being formed. Now, remember, when you are using ammonia, you're going to form primary amide, which means amide that has 2 hydrogen, because 1 hydrogen must go from your amine derivative. When converting esters into amide, is called aminolysis. In that case, the same thing that happened here also happens, but in that case, the product form differs. In formation of ester, methoxy was being formed from carboxylic acid. Remember, this end that is highlighted in green was the end that was bearing the hydroxy group. So in leaving, that is the end that will leave, and amine will replace it. And when it's going to go with 1 hydrogen from amine. That's why we're forming methanol from methyl benzoate. Then forming an amide, which is called benzamide. The general reaction of acid derivatives. Remember, the most reactive form of carboxylic acid is acid halide. So when this acid halide, we add water, we call it hydrolysis, forms carboxylic acid. When you react with Grignard reagents, you are going to end up forming an alcohol. When you react with alcohol, we call it alcoholysis, you're going to form an ester. When you react with amine, when you react with ammonia, it becomes aminolysis, you come forming amide. When you do reduction, you're going to form aldehyde, which under further reduction forms alcohol. Remember, carboxylic acid under reduction forms an alcohol. So for this reduction to occur, it is 2 steps. The first one is going to form an aldehyde. Further reduction forms an alcohol. Nitrile. When carbon is bonded to nitrogen, we call them nitrile. And hydrolysis of nitrile will always give carboxylic acid. So nitrile are carboxylic acid derivatives. Nitrogen is sp hybridized, making it that the lone pair of electrons are tertiary high because S and P character are 50-50. So they are not very basic. They are tending towards acidity. So this is how do I name this nitrile? For you to name nitrile, add nitrile to the alkane name. How do we substitute in synthesis of carboxylic acid derivatives? Now, we can readily convert a more reactive version of this carboxylic acid to a less reactive one. And reversal is the case, but it takes more than one approach. So it's easier to reverse from carboxylic acid derivative that are strong to the lesser one. Example, from acid chloride we can form anhydride. We can also form thioester. We can also form ester. How does acid halide react? Just like we said, under hydrolysis we form carboxylic acid. When reacting with a carboxylic acid, we form acid anhydride. When it's going to react with alcohol, we form ester. With ammonia, we form amide. Under reduction, we form aldehyde, and further reduction to alcohol. When react with mineral reagent, tertiary alcohol is formed. Reactions of acid anhydride. This anhydride is similar to acid chloride in reactivity, though acid chloride is more reactive than anhydride. Then under hydrolysis, we still form carboxylic acid, but in this stage, we are forming 2 mole of carboxylic acid. Under alcoholysis, we are going to form carboxylic acid. Under aminolysis, we are going to form our amide. Under reduction, we are also going to form aldehyde and further alcohol. What is the application of this acid derivative? In acetylation reaction, these acid derivatives are going to be used to form aspirin. Aspirin is blood thinning agent that helps in lowering or managing blood pressure. This aspirin is also useful in treatment of acne. So when salicylic acid reacts with acetic anhydride, an ester formed is called aspirin. The next application is in preparation of esters. Esters are used as flavors or fragrance. They are also very present in vegetable oil. Amide are abundant in living organisms. We see them in our protein, nucleic acid, and also some of the drugs contain this amide. You can see amide in that penicillin compound. Come to the end of this class. So see you in the next class, which is Introduction to Amine. Thank you.